Welcome class. So today we're going to be talking about lesson 2-2. We're talking about the relationship between two quantitative variables. So the essential question that we want to address today is, how can we visualize as well as determine if there's an association between two quantitative variables? So our learning goals for today are to be able to distinguish between explanatory and response variables for quantitative data. We want to make a scatter plot to display the relationship between two quantitative variables. And we want to describe the direction, form, and strength of a relationship that is displayed in a scatter plot and identify any outliers. So let's talk about the scatter plot. So in this lesson, we're actually going to be addressing the scatter plot, how to construct a scatter plot, and use it to describe associations between quantitative variables. All right, so remember that in chapter 1 we introduced ways to display the distribution of a single quantitative variable using dot plots, stem plots, histograms, and box plots. This time we want to display the relationship between two quantitative variables, and the scatter plot is usually the best way to do that, although there are other ways to do it as well. So the scatter plot shows a relationship between two quantitative variables measured on the same individuals. So usually the values of one variable appear on the horizontal axis, and then the other variable appears on the y-axis. And the actual data points appear as points on the graph. So here's an example of a scatter plot where we're comparing two variables that are quantitative. So we're comparing price to the weight in carats. So remember that each data point is displayed as a dot as shown here. And the point of this is to be able to see, is there a relationship between the weight in carats of this product and the price? So first off, we need to be able to identify explanatory and response variables. So remember that a response variable measures the outcome of a study, and it's usually what is being predicted. The explanatory variable, on the other hand, can help predict changes in the response variable. So remember that there's not always a clear-cut explanatory or response variable for every example that we have. So in that case, when you're making a scatter plot, if there is no clear explanatory or response variable, you want to make sure that you understand that there is no explanatory or response variable, and then in that case you can put either the explanatory or response variable in either the x-axis or the y-axis. So in that case it won't matter which axis demonstrates the explanatory variable or response. This will make sense in a little bit. So we want to identify the explanatory variable for the following relationships. So when we're talking about average income and life expectancy in a sample of countries, we need to identify which variable, income or life expectancy, describes or helps us predict the other. So in this case, if you think about average income, we can probably think of that as being able to predict the life expectancy if we're talking about this logic, this reasoning. So if you have higher income, this probably means that you're able to spend more on medical care, which probably means that you're going to have a higher life expectancy. So using that logic, we can say that for part A, the average income can be considered the explanatory variable. And we can say because a higher income may lead to better medical care, which could help us predict the life expectancy. All right, so let's look at part B. the heights of husbands and the heights of wives in a sample of married couples. So in this example, there really does not seem to be a relationship between the height of husbands and the height of wives. So kind of looking at it, there's no reason that there will be a relationship between the height of husbands and the height of wives. So in this case, the explanatory variable could be either one. So we're going to say that the explanatory variable could be the heights, could be either the heights of the husbands or the wives. And we could say because either variable can actually be used to help explain the other or predict. All right, so like we said, sometimes you're going to have a clear-cut explanatory variable, sometimes you won't, and then you could say that it's either one. All right, so let's talk about making a scatter plot. So in this problem, we have the 40-yard dash times in seconds and long jump distances in inches for a small class of 12 students. So we want to make a scatter plot to display the relationship between the 40-yard dash times and the long jump distances. So first things first, we want to label the axes. So we want to draw an x and a y axis, and we want to label the explanatory variable on the horizontal axis and the response variable on the y-axis. So like we said earlier, if there is no explanatory variable, then this variable can go either on, so either variable can go on either the horizontal axis or the vertical axis. So it doesn't really matter which one is placed where. So first off, in order to do this step, we need to actually identify the explanatory variable. Afterwards, you want to scale the axes. So you want to put the name of the explanatory variable into the horizontal axis, and then you're going to scale the axis by placing equally spaced tick marks along the axis. You want to do the same thing for the vertical axis, and then for the final step, you want to plot the data values individually for each data point. All right, so let's talk about labeling the horizontal and vertical axes. So what is the explanatory variable here? So in this case, if you're talking about the dash time, this would actually help predict the long jump distance. So the faster, so if you notice the faster the dash time or the longer the dash time, so if you look at 5.41 seconds as opposed to 7.17 seconds, so the longer the dash time, the shorter the long jump distance. So now if you think about it, that makes sense, because if you're having a longer dash time, that means that you're actually going slower, so you're moving slower, so you have less of a speed. And so we can kind of see that a faster speed probably corresponds to a greater long jump distance. So we can kind of see a relationship between those two. So therefore, we'll say that the dash time is the explanatory variable. So that's the explanatory variable on the top row. So we're going to have dash time here in seconds, And then we're going to have long distance on the y-axis. And this is going to be in inches. Okay, so we're going to start at 0 like we normally do. And we're going to go by 20s here. All right, and then for the dash time, we're going to actually start. So for the dash time, we can start at 5 seconds and end at 7.5 seconds. If you look at our data, the data does not go below 5 seconds, and it does not go above 7.5 seconds. So we'll start at 5-second mark. And then we'll go by 0.5 seconds. All right, so now that we scaled the axis, now we want to plot the individual data values. So we have 5.41 and 171 inches. So that's around here. 5.05 and 184. So that's around there. 7.01 and 90. Seven point 17 and 65. And so on. We're going to continue plotting all of the points. All right, so here is all of the data plotted. Now, when you plot the data, you can actually see if there's a pattern in the data. So it seems like the greater the dash time, as we were saying earlier, the greater the dash time, the shorter the speed of the individual, and then the shorter or the smaller the long jump distance. So there seems to be some kind of relationship between the two variables. All right, so when we're looking at a scatter plot, we want to address these following characteristics. So there are 4 main characteristics we want to identify. First off is the direction. So we want to look at positive versus negative versus no association. So remember, association is the relationship between the two variables, whether it be categorical or quantitative. So here, the larger values for positive association, the larger values of the explanatory variables lead to larger values of the response variable. And that's what we call a positive association. So the data points tend to be going upward like this. As the explanatory variable increases, then so does the response variable. A negative association is the complete opposite. So as the explanatory variable increases, the response variable decreases. So it looks kind of like this. As the explanatory variable increases, the response variable decreases. And then no association is when you have a complete randomness. So there is no pattern of increase or decrease. It's completely random. So for example, you have dots everywhere. There's probably no association that can be clearly distinguished here. The second thing you want to find out is the form. So you want to be able to determine, is this relationship linear or is it nonlinear? So linear, it just, you're looking at the pattern to see if it follows a straight line. And nonlinear, it does not follow a straight line. So it follows either like a curve, such as an exponential curve, or it's completely random. So for the strength, that's the third thing we want to determine. And this is the difference between strong association and weak association. So you want to determine whether it's strong, moderate, or weak. So strong association, the points don't deviate much from the form identified. So, for example, if you identify the form as linear, so something like maybe something like this. So this is linear, right? So there, it tends to have some kind of linear pattern. Now, if the points don't deviate much from this line that I drew here, then we say it's a strong association, which in this case it looks like is a strong association. A weak association involves points that deviate quite a bit. So for example, if we have that same line, right, and we have points kind of very far apart from it. We have some points near the line, right, but we have other points very far from the line. So that would be a weak association. And then the last thing we want to identify is the outlier. So are there any outliers that fall outside this normal pattern that deviate? All right, so let's describe the relationship shown in the following scatter plots. So the first graph, the first scatter plot is actually the one that was demonstrated earlier as an example of a scatter plot, which was involving price and the weight in carats. So let's talk about the first part. So part A, price versus weight in carats. So let's talk about the direction. So in this case, there seems to be some kind of positive association. So as one increases, the other one increases. So we'll say that there's positive association. Between the weight in carats. And this example is actually talking about diamonds. So we're talking about the weight in carats for the diamond and the price of the diamond. All right, so now let's talk about the form. So there seems to be a curved nonlinear pattern here. So if you kind of look at it, it kind of seems like a curved pattern. In fact, it actually seems like an exponential pattern. So the price exponentially increases the greater the weight in carats, which kind of makes sense from our experience. If you have 4 carat diamond, right, that's going to be priced way higher than say a 1 carat diamond, and it's not going to be linear either. It's going to be blowing up exponentially because they're rare to find. Okay, so form. So we said that there is a nonlinear. So there is a curved or nonlinear pattern. What about the strength? Well, since we know that it's a nonlinear pattern, and based on the curve that I drew, the points are pretty close to that curve, right? So we could say with a high degree of confidence that this since the points don't vary very much, the association is strong. So we have a strong association. Because the points do not vary much from the pattern. All right, now let's talk about outliers. Are there any outliers? So when we're talking about outliers, we want to see, are there any patterns that stray very far from the curve? So if you look at the curve, there's not any points that stray very far from this pattern. So we can say that there are no outliers here. So there doesn't appear to be any. So we want to see there doesn't appear to be any outliers departing from the curve pattern that we see. All right, so let's look at the second one, part B. So again, talking about the direction. So if you look, there seems to be a negative association between the two variables. As one increases, the other one decreases. So this is the example that we looked at earlier with the dash time and long jump distance. So there is a negative association. As the dash time increases, the long jump distance decreases. All right, so now what about the form? Well, if you look at the form, it seems to be going linearly, right? Like a line. So you can kind of see the line, and then some are departing from that line, right? So we can see a linear trend for sure. All right, so then let's look at the strength. So if we look at the strength, right, we can kind of see the line, and we have some points that vary some, right, between that and the line. They don't vary too much, but they do stray a little bit. So this is not really weak. Weak would be if they're farther apart, maybe like farther from the line. So now, so I would say that this would be a moderate association. So not too strong, but not too weak. So they're not too tightly clustered around the line, but they're not too far from it either. So there is a moderate so there's a moderate strength. I guess we could say strength. And we're talking about the strength, we're talking about the association. So the association is a moderate strength. Because the points vary somewhat from the linear trend. So now let's look at outliers. Do we have any outliers? It doesn't seem to be any numbers that stray, way too far. So like if we had one out here, that would probably be considered an outlier. So we can say that there does not appear to be any outliers. All right, guys, so that's it for lesson 2-2. In the next lesson, we're going to actually extend this concept further and talk about specifically linear trends and correlation. I hope you learned something from this video, and I'll see you in the next one.